Today we are exploring an agent-based model designed to simulate the effects of social interaction on collective behavior regarding the reduction of resource consumption. This model captures key social and psychological mechanisms that enable and amplify environmentally sustainable lifestyle through ICT tools. Specifically, this model examines the role of social norms, how they encourage sustainable consumption. The model integrates in-home smart metering services as a key elements of a digital ecosystem to explore how environmental awareness spreads and influences resource consumption. So, before this conversation, could you please introduce yourself?
My name is Giovanna Sissa. I work at the Genova University. I teach at the Doctoral School of Engineering.
To start, could you discuss the main objectives of this model and what aspects of decision making in sustainability and resource consumption are you most focused on? And how does the model address the impact of social influence?
The main objective of the model is to study the role played by environmental awareness and the spread mechanism of such awareness in order to modify the behavior of agent of the system. The agent of the system are household that have a fixed position on the ground. They can build. They can be in a country, in a city, for example, and the basic idea is that is the awareness level driving the behavior in resource consumption. So if we will arrive to understand how environmental awareness level spread, we can better understand how people can arrive to reduce their own resource consumption, and in particular electricity or water.
What were some of the important challenges you encountered while developing the model? Was it difficult to simulate the dynamics of awareness diffusion and enforcement of social norms through social sanctions?
The main difficulties is to find a balance among complexity of behavior and elements affecting the final behavior, and the realistic possibility to simulate the behavior of people in reality. So the main difficulties is to find a balance, because it's very interesting and exciting to try describe the behavior and the awareness and the interaction among neighbors and the role of social norms and so on. But we have to find a balance. Otherwise, the model is too complex, and it's not possible to manage such a complexity.
As for the insights of the model analysis, what specific behaviors have emerged regarding sustainable resource consumption? Have there been any unexpected trends in how social influence, smart metering, or environmental awareness impacts behavioral change?
What is very interesting is that there are tipping points. There are some tipping points, and a good and balanced description of the model can allow to have some to foresee the behavior, the collective behavior. We start from the behavior of single agent, where the agent are households, and we have a final global goal that is a given amount of resource consumption reduction, starting from the interaction among agents, a collective behavior emerge, and sometimes there are specific feature related, for example, on the initial number of awareness of the agent. We have 5 types of agent, starting from the less aware, the negative toward the environment. I call it blind. There are indifferent agent, observer agent, green agent, and evangelist. And there are some constraint emerging running the model and trying to use it on a large number of with a large number of agents. There is some particular configuration related to the number of, for example, a blind agent. Blind agents are powerful because the negative influence can be strong. It can not permit the awareness that the awareness level of each agent improve. The awareness level is a function of each agent, and each run, if the awareness level of the agent change, there is a threshold. The agent change type. One agent can pass from for example, to be an observer agent to become an green agent if its awareness level reach the threshold. And so each run, the population totally is different. Is different. Each each individual agent has an individual consumption. The overall consumption is related to that. The evangelist agent are prosumer, so they are able to produce himself the resource. For example, in the case of electricity, with solar power or other individual electricity plants. So there is a collective behavior emerging that is not easy to foresee, looking only at the individual behavior of the individual agents. And this is very interesting to observe, to try to configure, to reconfigure, and so on. At the end of my modelization, I have also a validation of the model with the real data from a real community supplied by an utility company. And really, I found a match between the results of the system with the results on field of a real situation.
You have made the model available using comsys.net. Did you face any challenges in preparing it for, public use, especially in terms of documentation, using ODD protocol, and the reusability of the model?
I found the organization of Comsens network was simple to use, well done. So no, I haven't found any particular difficult to make public my model.
What do you see as the next steps for this model? Do you have plans to, expand its applications or explore additional factors that influence the adoption of sustainable consumption behaviors?
It will be interesting to try and use the model on a different kind of resource, for example, on water, because the psychological ownership mechanism, the social influence, the social norms are very similar between the user of a resource like electricity or energy and water. I don't have this availability of data and this and the possibility to experiment the model on the other resource, but I think that the natural follow-up will be to try and use it on another on the use about the use of another kind of limited resource, or in any cases resource that we have to try and reduce.
Thank you. Thank you very much for joining me and for this conversation.
Thank you to you for this opportunity for me.